The suspension joins a car's wheels to its body, absorbs and dampens the impacts of uneven road surfaces, dampens the vibrations of the body and wheels, allows relative motion between the wheels and the vehicle, and transfers forces acting on the wheels to the body. Suspension is classified into dependent suspension, independent suspension, semi-independent suspension. A system in which two wheels on an axle are firmly attached to one another is known as a dependent suspension system. As a result of their independence, the wheels tilt at the same angle as one travels over uneven terrain. The wheels are attached to a rigid beam. Except for some SUV models, this style of suspension is rarely found in contemporary automobiles. It is widely used in trucks, though. Independent suspension. An independent suspension system is a system in which two wheels of an axle are independent of each other. When the car goes over a bump, one of the wheels can change its position without affecting the other wheel. Different types of independent suspension systems are possible, with the McPherson strut being the most popular. The majority of current automobiles have independent suspension systems on the front axle. Automobiles in the middle and top tiers frequently feature independent suspension systems on the rear axle as well. Semi-independent suspension. A semi-independent suspension system is an intermediate link between the dependent and the independent systems. A torsion beam is used in place of the rigid beam in this arrangement, and because of its capacity to twist, it lessens the dependence of the wheels on a single axle. It is installed on the rear axle of many lower-tier and mid-tier cars. Now, let's examine the structure of the front independent suspension using the example of the McPherson strut and the double wishbone suspension. These suspension systems include a wheel hub. In this instance, the hub is mounted on a steering knuckle. Suspension links, control arms, and beams. Springs, shock absorbers, an anti-roll bar. Suspension mounting elements. Note that one part can have more than one function. For example, the strut in the McPherson suspension system may serve as a shock absorber and a control arm. Let's go through the structure of a semi-independent suspension. Its key element is the torsion beam. The wheel hub is mounted directly on the beam. Let's take a closer look at the suspension components. Wheel hub. The wheel hub joins the wheels to the control arms, enabling their rotation. You can see a wheel hub and a hub bearing installed in the steering knuckle. The hub is attached to the brake disc and the wheel and is mounted on the steering knuckle via the hub bearing, allowing the wheel to rotate. The steering knuckle has fastening holes for various components, such as the brake caliper and control arms, as well as the tie rods that turn the steering knuckle. The rear suspension uses a rear knuckle. Sometimes the wheel hub and the hub bearing are mounted directly on the beam. Moving on. The appropriate movement of the wheels in relation to the body is ensured by a variety of suspension links, arms, and beams. They also transmit lateral and longitudinal forces that are applied to the wheels. In this case, such parts include the arms and the strut of the McPherson system. To ensure a flexible connection, the arms are outfitted with rubber bushings and ball joints, which we'll discuss later, while the strut uses an upper strut mount with a bearing. Springs. Spring deformation occurs as a result of outside forces. When the outside influences cease, they take on their original shape. Car springs primarily absorb and transmit vertical forces that act on the wheels. Their deformation allows to smooth down the impacts of uneven terrains on the vehicle. Apart from coil springs, some designs use torsion bar springs, leaf springs, and air springs. A torsion bar spring is a metal rod that can twist. It is rarely seen in cars, but is common in multi-axle and tracked vehicles. A leaf spring is made up of several metal sheets. If we talk about automobiles, such springs are only used in some SUVs, but they are widely used in truck vehicles. An air spring is a rubber cylinder filled with air. Due to its compressibility, air serves as a spring in this design. Although pneumatic suspension systems with air springs offer exceptional performance, they are mostly employed on high-end automobiles due to the complexity of the entire system and the high cost of maintenance. It is widely used in trucks and buses. Coil springs are the most frequently used springs in automobiles because they provide acceptable driving characteristics and are reasonably priced. Moving on to shock absorbers. Shock absorbers absorb and dampen vibrations and shocks, including spring oscillations that affect the body and the wheels, improving traction and comfort. You can see a suspension system with shock absorbers working to absorb and dampen vibrations. The shock absorbers aren't functioning right now, and you can see that without damping, the body begins to swing and the wheels experience vertical oscillations. A typical shock absorber for a passenger car is constructed as a telescopic tube with an oil-filled working cylinder. The piston valves allow the oil to go from one chamber to another when the shock absorber is in use. The resulting resistance dampens the oscillations. The shock absorber in a McPherson suspension system also functions as a control arm. Such shock absorbers are strengthened to withstand lateral forces and are known as struts. Anti-roll bar. The anti-roll bar is a U-shaped torsion bar. It can be connected to the suspension's moving parts directly or via anti-roll bar links. The center portion of the bar is attached to the frame or body with anti-roll bar bushings. If both wheels cross a bump, the anti-roll bar rotates in the bushings. If just one wheel does, the anti-roll bar twists, causing the other wheel to move a little as well, making the wheels somewhat dependent on each other. What use does the anti-roll bar serve? It enhances vehicle handling and safety by reducing body roll during cornering. As you may know, when a car turns at a greater speed, its body tilts due to the centrifugal force. This causes the inside wheels to lift off the road and lose traction, which may ultimately result in the loss of control over the vehicle. The features of the anti-roll bar in this instance allow it to twist and lessen the roll of the vehicle. Suspension mounting elements. The suspension mounting elements connect all suspension components to each other, the body or frame. Since many parts of the suspension move relative to each other, most of them employ flexible joints. These comprise rubber bushing, ball joints, upper strut mounts, and anti-roll bar bushings. The subframe is used as an intermediate fixture element. A rubber bushing is made up of two metal sleeves jointed by a rubber insert. The rubber insert gives the bushings the stroke appropriate for this design and allows them to partially dampen the suspension's vibrations. rubber bushings are fitted into another component and the inner sleeve is bolted. Rubber bushings are a common component found in various suspension parts such as arms, torsion beams, shock absorbers, and the subframe. The ball joint. A typical ball joint in the suspension system is made up of a ball stud, fitted in a metal housing with a plastic insert in between. The ball joint can swing and rotate, allowing the components it connects to move relative to each other. It joins the steering knuckle with the control arms. The ball joint can be detachable, or it can be integrated with the control arm to form a single assembly. Ball joints are also found in anti-roll bar links, the outer tie rod, and the inner tie rod. The strut mount. Shock absorbers are attached via rubber bushings. The upper strut mounts in the front shock absorbers, however, feature a different kind of fixture. In case of the McPherson strut, the upper strut mount must allow the strut to rotate, as its bottom is rigidly attached to the steering knuckle. The rotation is made possible thanks to the bearing, known as the strut bearing. To contain minor movements of the shock absorber and reduce vibrations, the strut mount also uses rubber joints, which are similar to rubber bushings. Other front suspension systems may look similar, but they might not include a shock absorber that can rotate, and the upper mount will then lack the strut bearing. Moving on. The anti-roll bar bushing is quite similar to the rubber bushing. It features a cut that enables it to be mounted on the anti-roll bar before being attached to the body or frame. The anti-roll bar can freely rotate within the bushings. Subframe. The subframe is a rigid frame that serves as a support for some suspension parts. It can be mounted on both the front and rear axle. It can also be used as a support for the engine, transmission, steering mechanism, and other systems. In the absence of a subframe, the suspension is attached directly to the body. As a last point, let me mention that tires also take up and partially dampen surface irregularities. The more air a tire contains, the better it can absorb any road defects, but the worse the handling. Our examination of the automobile suspension systems is now complete.
Ride Control, the world's fastest reacting suspension system, adjusts to changes in the road surface, improving handling without the traditional trade-off of harshness.
Magnetic Ride Control can read road surfaces as quickly as 1,000 times per second. The system has a wide variable resistance, so it can react to virtually any road condition. The result is a smooth and well-handling vehicle. Magnetic Ride Control technology is based on the use of electromagnets. Each damper is filled with metal particles suspended in fluid along with an electromagnet. When the electromagnet is charged, the particles align, creating more resistance in the damper. When the system is not charged, the particles float freely, creating less resistance. It's this variable resistance in the dampers that gives Magnetic Ride Control its extraordinary ride quality. Sensors in the Magnetic Ride Control system constantly monitor the heave, pitch, and roll of the vehicle. When a change is detected, the electromagnet charge varies accordingly, responding to virtually any driving, road, or weather condition.